points to keep in mind when we're proving trigonometric identities, and we'll look at a few procedures here that we should always keep in mind. And the first one is that you take one side of the identity you're trying to prove, either the left hand side or the right hand side, and you usually start with the more complicated one. Start with the more complicated side, as it's usually easier to reduce the complicated side to a simpler one, and then you make it look like the other side than it is to start with the simpler identity and expand it. So it's always easier to start with the complicated one. The second point to bear in mind is that you should study the identity that you're given carefully. Study the identity you're given carefully and keep in mind what you're given and what you want to arrive at. So you want to keep in mind what you're given and what you want to arrive at. Now the following relations here will help with the necessary substitutions that you might be making when you're trying to prove an identity. And one of them is that sine theta over cos theta equals tan theta. The second one is that sine squared theta plus cos squared theta equals 1. The third one is that 1 plus tan squared theta equals sec squared theta. And what is sec squared theta? Sec squared theta is 1 over cos squared theta, because sec theta is 1 over cos theta, so sec squared theta is 1 over cos squared theta. Now the fourth identity you want to keep in mind, or relation you want to keep in mind, is that 1 plus cot squared theta equals cosec squared theta. Cot squared theta is just 1 over tan squared theta, and cosec squared theta is 1 over sine squared theta, because cot theta is 1 over tan theta, and cosec theta is 1 over sine theta. So those are a few things you want to keep in mind. Then you want to express the trigonometric ratios that are involved in the identity in terms of sine and cosine, as those are they're always very easy to work with. So whatever you're given, try to see how you can relate it to a sine and cosine function. So now let's look at this example on our right here, and we're asked to prove that 1 plus sine theta over 1 minus sine theta equals sec theta plus tan theta in brackets squared. So if you notice, you see that the one on the right hand side is kind of complex. Instead of having sine and cos, you have sec and tan. So let's go ahead and walk with that one, and let's try to see if we can prove that it's equal to this one. So using the right hand side, this is the right hand side, sec theta plus tan theta. Now we said that sec theta is 1 over cos theta, so we can rewrite our sec theta as 1 over cos theta, and we can rewrite our tan theta as sine theta over cos theta. Now there's supposed to be a square here, but I missed that, so it's supposed to be a square there. So if we go ahead and add these two together, you see that they both have the same denominator, cos theta, so we can rewrite this as 1 plus sine theta all over cos theta, since they both have cos theta, and then we have a square here, so I remember to put it here. So if we go ahead and square this, multiply the one at the top, 1 plus sine theta by 1 plus sine theta, as we have here, and multiply cos theta by cos theta here. We went ahead and squared what we have here, and this is what it's going to give us. So 1 plus sine theta multiplied by 1 plus sine theta over cos squared theta. Now remember from here, this identity, that sine squared theta plus cos squared theta equals 1. Now we have cos squared theta. If we make cos squared theta the subject of this formula and we move this sine squared theta here, we'll have that cos squared theta equals 1 minus sine squared theta, because if you move the sine squared theta here, it becomes minus sine squared theta. So cos squared theta equals 1 minus sine squared theta, and then we have our top as it is. We also have it here, 1 plus sine theta, 1 plus sine theta. Now 1 minus sine squared theta, we can rewrite this as what we have here, 1 minus sine theta, 1 plus sine theta. Why? This is also known as a difference of two squares, because you know that 1, we can also write 1 as 1 square. Now jump with me over here. You have 1 minus sine squared theta, so we can write 1 minus sine squared theta as 1 square minus sine squared theta, because 1 square is the same thing as 1. Now look at this brief example. 9 minus 3 square, we can rewrite it as 3 square minus 2 square, because 3 square is the same thing as 9. And 3 square minus 2 square, you know that 9 minus 4 is 5. But if you use a difference of 2 squares, you can rewrite that as 3 plus 2 multiplied by 3 minus 2. Now 3 plus 2 is 5. 3 minus 2 is 1. So 5 times 1 leaves you with 5. So the same thing we did here, writing 3 plus 2 and 3 minus 2, we do the same thing here. So 1 square minus sine square theta is going to be 1 minus sine theta, 1 plus sine theta. Just like here, 3 plus 2, 3 minus 2, so 1 minus sine theta, 1 plus sine theta. So we've replaced our 1 minus sine squared theta with 1 plus sine theta, 1 minus sine theta. Now 1 plus sine theta cancels 1 plus sine theta from above. And then we're left with 1 plus sine theta over 1 minus sine theta. So you see we've reduced the right hand side of this, and this looks exactly like what we're given on the left hand side. So if they look the same, it sure means that they're equal to one another. So we've proved that 1 plus sine theta over 1 minus sine theta equals sec theta plus tan theta squared. So if you enjoyed this video, hit the subscribe button and check out the rest of our trigonometric identity videos and the rest of our videos. You enjoy them as well.